weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
I'm your host, Trent Ford, the Illinois State Climatologist for the Prairie Research Institute. Every morning, meteorologists predict the weather and often talk about what the future will bring, whether there's a likelihood of rain or a line of thunderstorms coming to your state. It's part of the norm in our everyday lives.
We continue with the heat. 109 in Phoenix today. It'll be 91 in New Orleans. So we're looking at heat that stretches all the way across to the east. That's what's going on around the country. Here's what's happening in your neck of the woods.
The strong to severe storms are now moving through from central Florida up through the Carolinas. You can see a little severe thunderstorm warning at this hour.
But it wasn't always like this. Back in the day, predicting the weather was viewed as impossible as looking into the future. Today, we look back at how weather forecasting evolved from guesswork into modern science. Joining us to explore the history of meteorology is Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Science at the University of Illinois, Urbana-Champaign. Hey, Jeff.
Hey, Trent. It's great to be back.
So this is really interesting and kind of spawned by this upcoming movie of forecasts during World War II called Pressure. So it kind of sparked us as let's look back and think about the history of forecasting. So during the mid-19th century, weather forecasting was seen as a pseudoscience. Weather forecasters today would be seen as wizards or fortune tellers, especially with the amount of time that they can give warnings ahead of a hazard. So, Jeff, can you tell us how we used to observe the weather way back when and why weather forecasting was seen more like magic than science?
Right. So if we go back to, the 1800s or the first half of the 20th century, a lot of what we have to look at the weather today didn't exist. For example, satellites. First satellite wasn't launched in orbit until 1960, I think, 1959, somewhere in there. Radar was kind of pioneered around and during World War II, but it was used mainly for wartime activities, looking at incoming planes and so forth. There were some surface stations that, kind of came online, especially in the late 1800s, around 1880 or so. Our weather balloon, upper air observations, again, those didn't really start until 1930s, 1940s, because we weren't flying, right? If you're 1900, right, you're not flying there.
Yeah, so obviously we didn't have the measurements. That's a key thing that you just mentioned, especially the upper air and the satellites. We also didn't have the technology like models, right? So in fact, like folks like Lewis Fry Richardson tried to forecast the weather using purely mathematics in the early 1900s, which seemed to be pretty challenging. Can you tell us what Lewis Richardson was trying to accomplish and how he attempted to predict the weather using math?
So basically, Lewis Richardson sat down with a bunch of paper and a pencil and looked at some of the weather observations from a certain day across the continent of Europe and attempted to basically do all this math by hand to make a 24-hour forecast. And it took him a year to do it, and the forecast was not very accurate at all. So he was very discouraged by this, and he actually said, here's his quote, "Perhaps someday in the dim future, it will be possible to advance the computations, basically make a forecast, faster than the weather advances," right? We want to forecast, not a hindcast, right? We don't want to forecast from a year ago. And at a cost less than the saving to mankind due to the information gained. But that is a dream. So basically, we can't, have 1 million people doing this, right? You have to pay them and it's too much money. And of course, obviously weather forecasting is a big cost savings, right? It's one of the best return on investments for the U.S. taxpayers, what goes into weather research and weather forecasting.
Yeah, and we're not talking the 1600s here, right? This is 1922. I mean, this was only a little over 100 years ago. I mean, we'd been taking weather observations here in Champaign-Urbana going back to the 1880s, and to think about, of course, 1922 is a little ways ago, but not that far back. Thinking about folks saying, experts saying, "Oh, this is a pipe dream for the dim future," is really, it really shows us how much progress has been made over the last 100 years or so.
Oh, yeah, absolutely. And of course, I mean, 1922, yeah, they had cars.
Yeah.
Right. I mean, think about it. They had cars. Cars had been invented. Crude airplanes, I think, were taking flight. Certainly we had locomotives and railroads, trains, those kinds of things. And you say, well, why wasn't meteorology more advanced? Well, the issue with meteorology that you don't see with chemistry or physics or biology, right? If you want to go look at cells, you can go do that under a microscope. But with meteorology, basically what we have to do is gather data across vast regions. And so you have to not only set up the observing network, but for those observations to be useful in making a forecast, we have to be able to transmit information across long distances quickly. So basically any dream of weather prediction or, modern meteorology was impossible until at least 1848 when they invented the telegraph. Because that was the first time that humans were able to, relay information basically instantaneously across long distances. Whereas before, right, you hear about, the Pony Express, which lasted something like 9 months, right? I mean, Express, it would take how many weeks to get out, or months to get out to San Francisco from Kansas City with letters and packages and stuff like that. And certainly, somebody gets on their horse here in Champaign and takes the weather report up to Chicago, well, the weather's going to beat you up there. So, so until the telegraph was invented, any dream of this was just it just couldn't happen.
Yes, we talked about how people archaically predicted the weather in as recently as the 1930s in some cases, or at least tried to. But as we got past World War II and entered the 1950s, we entered an era of technology that started to do math for us, or that we could at least replicate very quickly. How did early computer models change weather forecasting, and how did those really early versions of weather forecast models and computers actually look like, and were they accurate?
Right. So really what these early computer models, what they did is they proved, not only to meteorologists and the scientists that, yes, we can do this scientifically, but also, of course, it began changing the large-scale reputation of meteorologists. Whereas, think of, your grandma or your grandpa, right? Oh, my knee hurts, it's going to rain, right? Those kinds of folklore things. Or you hear about, the woolly worms or the woolly bear caterpillars, right? Looking at, what color that is, and are we going to have a cold winter or a warm winter or whatever. Of course, there's no science behind that. Sorry for our fans of the woolly worms out there. But it was just kind of a lot of weather folklore, right? I mean, things like the groundhog in Punxsutawney is based on weather folklore that the Germans brought over from Europe, basically looking at, if a woodchuck or some kind of rodent sees its shadow on what's called Candlemas Day, which is February 2nd, it'll say something about an early winter or early spring or a 6 more weeks of winter or what have you. So these early computer models actually demonstrated this is a science, that it's not, this pseudoscience thing, like people going out looking for Bigfoot or whatever, right? Pseudoscience. But these early computer models, they still weren't very good. The very first model that came out in the 1950s was called the barotropic model, where basically it just assumed that the temperature gradients didn't exist in the horizontal, to put it simply. Mm-hmm. And obviously we do have temperature changes in the horizontal, right? Just across the state or across the country, right? That does happen. And this model went out, it ran out 24 hours. It only ran at one level, which is, we call that 500 millibars. That's about halfway up through the atmosphere in terms of pressure. But it's about 3 miles high, or 3 miles high or 5 kilometers above sea level. And so you just got this one upper air pattern, out 24 hours, and it was very coarse, and you didn't have fields like precipitation. You didn't have fields like surface temperature, because it was 2D. And you say, well, why was it 2D? Well, your computers in the 1950s were not nearly as powerful, right, as they are now. What is it, Moore's Law, that says computing power doubles every, 5 years, 10 years, something like that. So computers were quite slow. Now, obviously, they were great for their time, but these computers, they basically took up an entire large-sized room, They ran on vacuum tubes, not microprocessors. You would have to walk over to the computer with a punch card to have it run your computer code, because every model is just a bunch of computing code, right? You compile it and run it on the computer. But these models were not very accurate, and so, right, okay, we're trying to battle for the reputation of meteorologists here, and then you start getting, oh yeah, these people are actually trying to predict the weather now, and oh, the weather guy is always wrong, right? Why would I get a job? It must be nice to be, get paid and be wrong, 50% of the time or 90% of the time. And because these models were quite inaccurate, that's kind of where some of that reputation comes from.
So if you're joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Trent Ford, Illinois State Climatologist at the Prairie Research Institute. We're talking about the history of weather forecasting with Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Science at the University of Illinois Urbana-Champaign. So let's get more specific here to one of the more impactful types of weather that we have, and that is a tornado. So here in Illinois, we might hear outdoor sirens, or better yet, your phone alert during a tornado warning. But weather warnings weren't always issued this way. I think about the tri-state tornado when folks first knew that was coming when they saw it come over the hill there in Murfreesboro, and how terrifying that must have been. In the 1800s, the U.S., the Weather Bureau banned the word tornado in forecasts because officials thought it would cause panic, and that ban lasted for 60 years. So, Jeff, before this ban, I was assuming the Weather Bureau banned it for a reason. Were there scientists who were trying to forecast tornadoes in the 1800s, and how did they try to do that?
Yeah, there were scientists, really in the late 1800s, obviously, right before you have the telegraph, right? It doesn't matter what you're trying to forecast, you're not going to be able to do it unless you're just looking up at the sky. But yeah, in the late 1800s, observing stations were coming online, and folks were beginning to construct daily morning weather maps. They would send the weather data to Washington, D.C., and meteorologists there would draw up the weather analysis. And, and they started to notice, maybe tornadoes are kind of occurring where it's really warm and muggy. They tend to occur a little more in the spring. And also we have to remember, too, that things were a lot less populated than they are now, especially across a lot of the central United States. So some folks thought that tornadoes and severe weather could be predicted. Some folks in the Weather Bureau, which was the forerunner of today's National Weather Service, some people thought they couldn't be predicted. And it turned out that the folks who thought they couldn't be predicted, that you're just scaring people, there's no skill in doing this, they won out. And so the word tornado was banned. I think it was around 1888, somewhere in there, that basically they said we're not going to use the word tornado in any weather forecast because we think we have no skill at being able to do this.
Yeah. So after this ban was issued, and during this ban, March 1948, destructive tornadoes hit central Oklahoma. And although the storm left a trail of devastation, it also led to the first, I guess, maybe operational or Weather Bureau, National Weather Service tornado forecast. Can you spin us a yarn how that all came to be?
Yeah, sure. So in March 1948, I think it was around March 17th, 18th, somewhere in there, middle of the month, Tinker Air Force Base outside of Oklahoma City was hit by a tornado.
The devastating power of the twister tore up the runways, rolled up the runways as if the wind were a giant hand of evil power.
Of course, we did not warn for tornadoes in those days. So the tornado hit unwarned, and it caused a lot of damage to the base and some of the aircraft. I'm not sure about the exact number of injuries and fatalities on this. And so then the base commander called in the two meteorologists here. Their names were Ernest Fawbush and Robert Miller, or Fawbush and Miller for short. And he said, gentlemen, if we're going to get hit with a tornado again, if you think we're going to get hit by another tornado, could you please try to let us know in advance, try to forecast this? And so it happened that a week later, on March 25th, 1948, Fawbush and Miller were looking at the morning observations and the morning weather maps, and they said, boy, this looks a lot like the day we got hit by a tornado. So they went and talked to their base commander and said, hey, commander, general, whatever, admiral, I guess, it looks a lot like the day we got hit. We might get hit again today. So they, prepared the base and probably moved the aircraft inside or something like that. Came up with what to do if we see a tornado coming at us, right? Had some plans in place. And fortunately, the tornado did hit the base. It was unbelievable that they got hit twice within 2 weeks, right? Even in Oklahoma, that doesn't happen.
Yeah.
But because the base was hit, it said, hey, there is actually skill in being able to forecast these things. And Fallbush and Miller, one or both of them, went on to work for what became the National Severe Storms Forecast Center that was in Kansas City, Missouri. And then in the 1990s, that office was moved and reorganized into today's Modern Storm Prediction Center in Norman, Oklahoma. And that's the organization that still issues severe thunderstorm and tornado watches, not warnings, but watches today.
So if you're joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Trent Ford, Illinois State Climatologist at the Prairie Research Institute. We're talking about the history of weather forecasting with Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Science at the University of Illinois Urbana-Champaign. All right, so we've talked a lot about the past advancements and sort of the anthology of the weather forecasts and tornadoes. So what are things looking into the future that you're excited about, innovations and otherwise in weather forecasting?
Right. We did a whole episode on this a couple of weeks ago, or maybe a month ago, but talking about artificial intelligence-based models.
Daryl Kleiss, Deputy Director of NOAA's Environmental Modeling Center, says the speed these new AI models produce a forecast is much faster than traditional weather models.
It will produce better forecasts with lower computational power to save lives and property.
And these AI-based models, instead of solving these very complicated equations at all these, thousands or millions of grid points through the world, through the atmosphere, instead they're trained on pattern recognition, so they run a lot faster. Now, it does take a lot of work to train these things, but once you have it trained, it can crank out a forecast a lot more quickly and a lot more efficiently than our traditional, we call them physics-based models. And right now, these are only operational for the large scale, but we think, there's some development work being done at NOAA and elsewhere, maybe looking at smaller scales, looking at severe thunderstorm scales, or maybe issuing probabilistic warnings. There's another project that's been worked on at NOAA for over 10 years now called Warn on Forecast, where, hey, right now we don't issue a severe thunderstorm or tornado warning until we have observational evidence to do that. Either a spotter sees something and reports it to the Weather Service, or the forecaster on duty sees a signature on radar and says, oh, hey, I should issue a warning for this storm. But it's right now kind of reactive on how we do that. But saying, okay, well, maybe half an hour from now, okay, the storm's going to get real intense. Well, right now we don't issue warnings that way because we can't really predict, storms all that well, right? We don't have a model that's actually simulating that data, at least on the fine enough scale that we need.
Yeah, that it's really interesting to see about the influence of artificial intelligence on forecasting, and as with everything, it's a really quickly and rapidly advancing field. So it'll be really interesting to see how that plays a role.
The first AI model, I think, wasn't publicized until like late 2023.
Yeah.
The data became available on that, and so in like 2.5 years. I'm looking at AI-based models as well as traditional models here as I try to look at the long-range pattern for our, storm observation.
So do you think with AI or otherwise, do you think weather forecasting will ever become nearly perfect, or will we always be making decisions under some uncertainty?
Yeah, I think there's always going to be some uncertainty. I think back to, you've seen it, Back to the Future Part 2. Which was set in 2015, which was 11 years ago.
You've got to come back with me. Where? Back to the future.
And as soon as, first time Marty McFly shows up in the future with Doc Brown, Doc had already been there. And he said, oh, he's getting up his umbrella or something. Oh, yeah, it's going to start raining in, 45 seconds or something like that. And there's just this downpour coming out of nowhere as they're standing, I think, in this alley between some buildings. We're never going to get that precise and that advanced, much less 11 years ago. Because, and there are certain reasons for that. Our physics-based models do make some approximations in how they solve these equations and represent, for example, changes in quantities both in space and in time. Right now, even our finest resolution model, we're running that at 3-kilometer grid spacing, so about 2 miles apart. So we can't see individual cloud droplets or individual rain droplets or the little small turbulent circulations that mix the atmosphere down near the surface, how the sun heats the ground and the ground heats the air above it. We don't have observations everywhere. If you look at the temperature in Champaign, you're getting the temperature from Willard Airport down on the south end of town. The National Weather Service in Lincoln launches weather balloons. The National Weather Service in Chicago, in Indianapolis, and St. Louis does not, and it's always been that way. That's not anything new there. But our weather balloons are, very sparse, twice a day, and we have, I think we had launch, about 100 balloons or something right around the country, the U.S. and, its dependencies. So because of, lack of detailed observations and, of course, approximations in these models, you're never going to get an absolute perfect forecast. But it certainly is improving quite a bit. So, like, for example, measured by some metrics, a 3-day forecast now is as accurate as a 5-day forecast 15 years ago. And you say, well, 3-day forecast, who cares? Well, now you say, well, what about you're now on a coastline and a hurricane is coming toward you? Actually, 20 years ago, the National Hurricane Center didn't even issue 4 or 5-day hurricane forecasts because there was just no skill in doing it. Basically, just taking a wild guess would be as accurate as their forecast that they put a lot of work into. And then once they demonstrated that, hey, these finally get skill, then they'll start releasing those products. So when the Weather Service or any, most meteorologists are coming up with a new topic, they're going to make sure to test it in-house first to make sure it's actually skillful. But, there are some weather websites out there that have, kind of ridiculous things like, 30-day and 90-day and, forecast out 10 months, looking at day-to-day weather. And it's just so far beyond the science that those things can't be taken seriously. And I think, you all know that if we go look at the weather for the 4th of July or, next Christmas.
Right.
Gonna
have a white Christmas this year?
No, I mean, with the big El Nino, probably not. Yeah. But, it's not saying, it's a warm winter, but you can get one big snowstorm that hits, and that's what a lot of people are going to remember. So
yeah. We've been talking with Jeff Frame, professor in Department of Climate, Meteorology, and Atmospheric Science here at the University of Illinois. Jeff, thanks for joining us on Weather Realness.
Thank you for having me again, Trent.
Have a weather or climate question you want us to answer? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu.
Weather Realness is produced by
Jeff Frame,
Trent Ford,
Steve Nesbitt, Reginald Hardwick,
Stephanie Orellana, and myself, Maddie Stover. Funding for this podcast is partially provided by the Backlund Charitable Trust. Weather Realness is produced by the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign and Illinois Public Media. We'll talk with you again next week.